Hi folks, Mr. Long here. We're going to do a screencast on, once again, another screencast on SOHCAHTOA, but what we're going to do is develop some relationships for the definitions of sine and cos inverse. Okay, and the way we're going to do that is go through and do some work with some triangles. So instead of working with specific ratios of 0.5 over 1 or 1 over 1, we're going to work with just in general with x. So let's go through this process. So here we go. So what we're going to work with is this triangle right here, this first triangle, number 1. Whoops, a daisy. I gotta get that. Sorry, folks. Number 1 here. And what we want to do is take a look at this triangle. First thing we're going to do is, notation. You're used to this notation, but most of the math world actually uses this notation, arcsine, instead of sine inverse, sine to the -1. And I think the background of that has to do with the invention of the calculator. Arcsine took up too much space to put on calculators, so they started using sine inverse. They mean the same thing. Okay, they mean exactly the same thing. So let's go through this. So here's a triangle, right angle triangle. That's angle y. It goes across to the opposite side. I always put my arrow across there, and I know that's the opposite, and then this is the hypotenuse. So opposite is x, hypotenuse is 1. We know that opposite and hypotenuse are related by sine. What we want to do is also get this side here, the third side. We want to figure out what that is. We're going to do that with Pythagorean Theorem. So again, we're going to be developing the definitions of sine inverse, okay? Equations for sine inverse. So the length of that adjacent side. So if I look at that from a Pythagorean theorem perspective, L, the third side, is going to be 1 squared minus x squared, right? That makes sense, Pythagorean theorem. Hypotenuse squared minus the opposite side squared. And then if I want to get length by itself, it's just going to be square rooting both sides. So I'm going to have 1 squared is 1 minus x squared. So that's the length. So now let's start doing some trigonometry. So we're going to start doing some trig. And as we go through and do some trig here, we know that we're doing the sine of angle y because we're working with the opposite and hypotenuse. So sine of angle y equals the opposite x divided by 1, which is really just x. By the way, the angle is y. The ratio is x divided by 1, which is just x. So what we have is sine of y equals x. Now, if I want to get y by itself, I need to apply the inverse. Well, what's the inverse of that? Sine inverse. The way I remove sine is sine inverse. Now, I could have written arcsine, but it takes up too much space, so that's why I'm not doing it. So sine to the -1 of x. I have to do what I do to one side, I have to do to the other. So now, what is sine inverse of sine y? Well, it's just like the square root of x squared, right? It's just x. So in this case, it's just y, and that equals sine inverse of x. So again, y is an angle, and the ratio is x. Now what I want to do is, I'm going to write in over here on this triangle. This triangle has a side length of 1 minus x squared. So if I look at the three sides of this are 1, x, and square root of 1 minus x squared. Okay, so here's what we're going to do. We're going to come up with definitions based on y being arcsine of x, okay, or sine inverse of x. So arcsine of x means, so what does that mean? What does y equals arcsine of x mean? Remember that this is a ratio. So it means that the sine is x over 1. Okay, so our ratio of our sides is x divided by 1. Whatever is in here, remember, is our ratio for sine inverse. Y is our angle. Okay, really, really important. I can't emphasize that more. It's all about recognizing that the argument, or the thing in the brackets inside of sine inverse or arcsine, is the ratio. So if I have that, if that's true, I know that sine y is automatically worth x. What's cos y worth for this triangle? So I go back over to this triangle over here with all this messy writing in it, and I want to do cosine of angle y. Well, there's angle y. Cosine is adjacent a divided by hypotenuse. So it's actually the root of 1 minus x squared divided by 1. Well, what's that worth? That's just worth the square root of 1 minus x squared. Okay, that's what cosine is worth, because again, it's divided by 1. Now let's look at what is tangent of angle y worth if and only if we're doing arc sine of x. So if sine of y equals x, then these are true. Okay, if sine of y equals x, then these are true. So what will tan y be worth? Tan y, so here's angle y right here, and tan is opposite x divided by adjacent 1 minus x squared. So I know that, whoops, this is going to be opposite x divided by square root of 1 minus x squared. So again, if and only if y is equal to arc sine of x, which means the ratio is x over 1 for sine, automatically that's x because it's x over 1, then I get these other two from this picture. Okay, we're going to try one more here, and then you're going to do, well actually I'll do tan, and then I'm going to have you do cos. Okay, I'll have you do cos. So tan right here. I don't know why that. I'm getting a line through there. Oh well, that's okay. Won't matter. It's still recording fine. So let's go through this and do the same thing for tan now. So for tan, it says that our tan inverse is x. So y equals tan inverse of x. Well, what's tan? Tan is opposite over adjacent. So if tan is worth x, then we know that its x is opposite divided by 1 adjacent. Okay, so if this value here is x, I know that, like remember that this is an angle and this is the ratio, right? X is the ratio. So I know the ratio, if the ratio is x, it's actually x over 1. So that means the opposite is x, the adjacent is 1. Okay, that is 1. Okay, so let's get the Pythagorean theorem for the third side in this case. So I'm going to call that L right here. That's called L. And in this case, L squared would equal, what would L squared equal? L squared would equal, well, it's this L squared is the hypotenuse, so it's going to be x squared plus 1 squared. Or we can actually write 1 squared plus x squared. It doesn't matter. Convention for inverse trig is to write 1 squared plus x squared. So we'll use this one here. If I square root both sides, I end up with L equals the square root of 1 plus x squared. Okay. Let's see. Let's go through this. Now we're going to do some of our math, right? So what we're doing here is we're doing the tangent of angle y, and that's worth x divided by 1. So again, the angle is y, the ratio is x. X divided by 1 is x. How do we do the inverse? I want to isolate for y. Well, I've got tan of y equals x. How do I undo that? I do tan inverse of that. And if I do tan inverse on one side, I have to do tan inverse on the other. So that gives me this side, tan inverse of tan y is just y, and then that means it's tan inverse of x. So my triangle has, a right angle triangle has an angle of y and a ratio of x over 1 for tan. Okay, that means this triangle right here is defined as having an angle y with a tan ratio of x over 1. That's how we read that. Okay, that's how we read that. So let's go over to here. And what I'm going to do here now is I'll draw out that triangle again right here so you can see it. So this is angle y. The opposite side was equal to x. The adjacent side was equal to 1. Okay, and this is the hypotenuse. And we found the hypotenuse to be the square root of 1 plus x squared. And now let's go through and do these. So we said in this case, tan of angle y, we already know is x. What's sine of angle y going to be? Well, sine of angle y, there's angle y there. Sine is opposite divided by hypotenuse. Opposite divided by hypotenuse. So sine of y is going to be opposite x divided by square root 1 plus x squared. Okay, so that's the sine of y if tan of y equals x. Again, if tan of y equals x. Finally, let's do cos of y. Okay, let's do cos of y. So for cos of y, cos I know is adjacent divided by hypotenuse. And I know the hypotenuse is right there. And the adjacent side to angle y is 1. So again, adjacent is 1, and the hypotenuse is square root of 1 plus x squared. Okay, and that's my cos of y. So those are the three ratios when tan of y equals x. Here's what I'd like you to do now. So you're going to do the number 2. So on your handout, you're going to fill in number 2 by yourself. So again, what you're going to do is work with cos. Okay, so you can see here, oh, first of all, angle y, I'd go across here to say opposite. We don't know the opposite, but we definitely know the hypotenuse is 1, and we know the adjacent is worth x. So what you should do now is pause the video, take a few moments, go through it, make sure that you're understanding everything. Okay? So what we'll do right now is we will pause this recording. Oh my God, it didn't record. What is recording? Stop.